Hi, everyone. Um, I'm Eran Sandler from AppSharp. Nobody knows it. That's fine. Uh, yeah, and we're going to talk a little bit about a Redis module that kind of started out as showing Redis modules at some point when modules came out. But it kind of became very useful at some point. So yeah, I'm the CDO of AppSharp. We make Site Booster service that helps small businesses get listed in all the right places. And I've been using Redis circa, I think, 2010, give or take, which is kind of old in various capacities. So yeah, we're basically going to talk about unique IDs, which is kind of sounds very uninteresting, but it's something everybody does, kind of like other things. So what is a unique ID? It's a unique identifier is a numeric or alphanumeric string that is associated with a single entity within a given system. UIDs makes it possible to address that entity so that it can be accessed and interacted with, which is basically any ID and every information you store either in Redis or you store it in your database. You need an ID to access it and make sure that that's the exact item or entity you're talking with. And basically there are kind of two different ways to generate IDs. One is what we call coordinated unique ID. So the most common one is, if you've used MySQL before, it's MySQL auto increment. You basically say, okay, this is a number. Every time I insert new information to the database, it will increase it by 1, and that's your main way of generating IDs. Main problems with pros of it, it's very easy to make it. You just use whatever you have. You can do your own counters to do that. Doesn't involve any services or anything. You usually just either have it there in your database or anything else, and it's usually sortable. Every number it grows by 1, so you know that newer items have higher values, older items have smaller values. The cons is that it becomes a bottleneck in a lot of environments. When you have a lot of services, a lot of requests that generates a lot of data, you need to generate these IDs very quickly, and you need to generate a lot of these IDs together. And if this is MySQL, for example, they have this own locking mechanism to make sure it increments by 1. If it's Redis, it's fast because you can say, okay, let's increment this counter, but it's still, it causes a lot of pain. If you have a distributed database like the ones they showed in the talk earlier, then you have, sometimes you have something that get disconnected and you need IDs and you can't coordinate these ID generations in the same place. So there's quite a bit of problems with coordinated IDs. Just an example, this is the auto increment ID from a table on MySQL that everyone knows. Uncoordinated IDs are something that needs little or no coordination at all. So the best example for it would be GUIDs, right? Everyone uses GUIDs. They're long strings. Everyone, it's easily generatable in every place, and they're highly used in a lot of places. However, there are a few problems with GUIDs, but we'll take a look at that in a sec. The pros is there is no coordination needed, so you can have two machines generate IDs, and in most cases there would be unique, and you can make sure they are not colliding with each other, and you can generate it in different places. You can generate them ahead of data insertion. So say you have this distributed database or a lot of services that needs to access the same information. So you need that ID and you need that to be accessible in different places. Sometimes before you insert the data, because it's going to get into, say, logging systems, and it's going to get, the data is going to get into the systems themselves. So pre-generation is a very common thing to do. The cons is that you usually need either additional server to do that, or some other way of code or making sure you're generating an ID that it is unique. To some, it might be a problem generating it outside of the, saving the information. On the other hand, you don't waste your IDs because you have enough of those usually. And most of them, and we'll see an example later, are usually time-based. So there is some component of time inside the ID, and that means that if you want to protect yourself from time skewing because servers are not synced in time, you need to make sure that they are. So that's your very basic common GUID that most of you used in the past. They're great, but they're 128 bits, which is kind of long for a lot of things. Their textual representation, as you can see here, is kind of horrific. You have these dashes, and these dashes can lead to problems when indexing them in various search systems. There are probably better ways to represent GUIDs in text. In most of the cases, UUIDs v4, GUIDs v4, which are completely random, they're not consecutive. So if you get a bunch of these IDs and you want to sort them, there is no guarantee of any type of sort. Some of them may have smaller lexicographical values, some of them may have larger values, but they're basically going to look very different, and you have no information of knowing just from the IDs which one was generated first. There is a type of GUID called UUID v1, which does have a time component, and we'll look at that later. However, to generate the rest of the information, it uses sometimes the MAC address of the network cards of certain computers, and that may expose information about the host that actually generated this computer, so most people don't use that. And again, unlike UIDs v1, UIDs v4 are completely random, or as much of randomness that they can be, and they cannot be sorted. So what do we want from unique IDs? We want them to be unique. Of course, we want them to be sortable, so even if we get a chunk of information that has certain records from different places, it can be IDs of event logs, it can be IDs of any other information. You want to make sure that you can sort and figure out which one was created first or later. Either it's sorting it by UI, say, like Twitter does with unique IDs, and they can sort your tweets just from that and not by figuring out the date from the information. And we want them to be uncoordinated or semi-coordinated, in the sense that we can generate them in different locations, different data centers, and different anything, in a way that will not either block because they need some central coordination, and that even if you have some kind of network fault between locations, we're not held back by that. So this is basically the general structure and anatomy of a case sortable unique ID. Most of them have, whatever length you decide them to have. They have the red part is the timestamp part, and it can be as detailed and as less detailed as you want. You can have it by a millisecond resolution. You can have it by a nanosecond resolution if you allocate more bits to it, and you have a chunk of random bits basically. That hopefully you're generating by a very secure random numbers generator. And that makes sure basically, again, as long as the random data is big enough that you can generate enough IDs in a certain period of time. So if you have a big enough block, you can generate in 1 millisecond, 1 million IDs, which is quite enough even for Facebook style scale. And these are a few examples of unique ID structures. So the most, I think, it's not the most common, but it's one of the first ones that kind of generated this whole thing. It's called Snowflake. Twitter started it in like 2010-ish. I'm not sure they're still using the exact version of it. It's a 64-bit number that is constructed out of a few things. They have the 41 bits reserved to time, so they have millisecond precision. They have region and worker IDs, which that's the part of that it's semi-coordinated, because if you deploy different services to generate these IDs, you want them to have slightly different versions. So say you have 2 services and in the US location and one in EU, in Europe, then you'll have different region IDs for each one. And for each worker that generates these IDs, you'll have a different worker ID. K-sortable unique ID, KSUID, it's a rather new one from I think it was from March. Segment, if you know Segment.io, segment.com, they've generated it. They made it slightly simpler. It's slightly longer. But it's also, again, based on a timestamp up to a millisecond resolution and a lot of randomly generated bytes. ULID is another proponent. The good thing about ULID is that it kind of looks like GUIDs. So if you have a system that already knows and a database that already knows how to get GUIDs and how to save them and how to use them, then you can just move to this algorithm and it's basically compatible. But you'll still get IDs that are sortable. So if you get a bunch of those, you can still know which one was created earlier. This is kind of a set of a bunch of others, other unique IDs that are being used. So Snowflake, KSUID, and ULID is the ones that I already mentioned. There is one that is based on what MongoDB, for example, uses, XID, and basically a bunch of others. Almost all of them use some form of the structure and anatomy that we talked about. So what is Redis Unique? It's a module that basically have multiple unique IDs implementations. Not as much as I would like to yet, but we'll have a bit more later. And why should you use it? So I assume you probably run Redis if you're here. And most of these things, you usually want some kind of servers to generate your IDs for you beforehand or whatever. So instead of running another service, another server, another instance that you need to monitor to make sure that it's running, to do whatever it takes for a service to do, you can just load up a module inside your Redis and just keep on monitoring the service and the system and the computer that you're already hopefully doing, and just use that to generate the IDs. You can integrate it if you're storing ORM information on Redis, either for caching or for any other reason. You can integrate that inside the generation of the data. So it's kind of like having your auto increment field in MySQL, where you just insert data and it will generate the ID for you. Then you can do the same thing here. And if you choose one of the case-sortable implementations, then you get IDs that are sortable, which is obviously cool and useful in a lot of cases. Specifically, for example, if you have some kind of an API that returns JSON information, and JSON is notoriously famous for not handling dates correctly, or basically only in string versions of it. And you want to sort this data by creation date or whatever other date. So either you have to store another unique style timestamp to do the sort, or you can just use the IDs and do a regular, if you have a case sortable ID, you can use a lexicographical sort on the IDs and you can sort the information. So it's very useful in these cases. Why was Redis Unique created? So first of all, I wanted to learn a little bit about how to write modules to Redis. The first version was kind of like my benchmark for studying things. I think since Twitter did this, Snowflake in 2010 became my benchmark for either evaluating new languages or platforms, and just it's just simple enough code to figure out how things work. So the original version was just Snowflake, but then I decided let's add some more things, so GUIDs and everything else. Unique IDs are fun, as much as they can be, and very useful. This is something that most people don't really pay attention to, specifically you're a startup or you're starting up your product. But at some point when you grow up and you have lots of information or lots of users, these kind of things start to generate blocks in your ability to grow. And again, it's not something you usually think about when you first start, but at some point it becomes a bottleneck. I personally hate to run dedicated services and machines just for doing anything. If there is something that I can do to squeeze in another thing that generates more functionality, and I don't need to monitor it, and I don't need to do anything else, then that's what I would do. And basically because I can write this module, I just did. And it was a fun learning experiment to write modules and kind of dust off my rusty C. So let's see a little bit of demo. So what I have here is basically a Redis server that I loaded up with the module. And the module itself is called Unique ID. So if I call Unique ID, for example, and I will do UID v1, then it will generate the ID for me. If I'll do v4, it will generate it just the same, again with Snowflake, and probably later on this week, a couple of other algorithms that will be added. The nice thing that we can do with all of that is that we can embed or basically proxy the generation of IDs into other commands. So if I do something like this, and I will do exec, and I will do set foo, something like this, in Snowflake, I will basically, it will proxy the command, so set foo will still move forward, and the Snowflake placeholder will be replaced by the actual ID. And the result, if you can see it here, will contain the ID that was generated and the result of the original command, the original command that was running. If we'll do get on foo, we'll obviously get this value. It's very useful in a bunch of scenarios. Say, for example, you have a hash that does that. And you want to set some kind of a field, say ID, before, then this will work just as well. And if you do fetch, you'll get it. So if you're instead of using scripts or anything, better to compose more complex commands, you can just have it flushed straight up to the information, to the object you're creating or the field you're setting. Any questions? Yeah.
What's a web use case for something for web development? What's a use case for this?
So obviously you're doing, you're generating. If no one heard the question, what was the use case for web development? So basically, you're probably storing information, somewhere in the database or anywhere else, and you want to get this information back to the front end. So like in the case of, say, Twitter, you want to get your tweets back to the front end and show them. And you might want to have them sorted. So instead of going back to the server, for example, and doing the sort and coming back, you can sort them in place in the browser because you have the IDs. And if the IDs are sortable, then you can easily sort it.
Can you use that as a key as a Redis key?
What?
The ID.
Let's
say because
you're
specifying it as a hash.
I haven't added that, but yeah, you should be able to do that. And for the hash, you would want something like this, right? So you would do like Snowflake.
Exactly, because
Yes.
like the Mongo
Yes,
ID
yes.
example you
You-
had was relevant.
What? I don't think it actually.
Knowing your code, it should work.
I don't think it does. Let's see. So
like named foo or something.
no, it doesn't. I don't think it searches. Only searches for parameters and not inside parameters. But I'll add that.
That could make.
No, but you can still like do set Snowflake bar and then create an object and have that object have a unique sortable ID. You don't have to use that as a value.
No, he wants it as the key name
Yeah.
itself. Yeah.
Yeah, but the problem here is that you had an underscore there.
No, I'm not sure it's the underscore. It will still.
No,
not
no,
do.
just
I know the code.
just unique ID exec set
Yeah.
Snowflake foo.
Yeah, you got to remove my hash because that's what it's.
Oh, yeah, that's sure.
Yeah, that will work.
That will work, but you usually want to prefix that. Yeah, foobar. Sorry, you wanted it age. No. I
And
guess
it crashed.
Make it a primary database.
Yeah.
Auto-generating IDs, and I have my
Yeah.
ID, and then I have a hash.
It's just, it should do that. It will, yeah. But that's the whole point, yeah.
Other questions?
I guess in your past, years of development, what IDs do you use? Have you used, for your databases and whatnot? Because to me, it seems like something like Mongo's Object ID or the XID seems the best of all worlds. Like you get the idea of generating the IDs of the client, it's sortable.
But it uses host information.
What's wrong with that?
If as far as I remember, the object ID of Mongo does put at some point uses the MAC address of the server.
Yeah.
So that may it's not that big of a deal, but it may expose information of the host that was generating it, and that's why some security experts are not very comfortable with that. That's why there's a bunch of others. I've used in the past Snowflake IDs because they're easy. They're kind of easy because they're 64 bits and they're basically just along, and that's very useful in a lot of cases. Even memory-wise, it's just that. And I've used. Recently, I've started using the KSU IDs that Segment uses. Again, they're much more easier or much more secure than the object ID of Mongo. But I agree, any case sortable one would be great and useful.
For your Snowflake implementation, there are some orchestration issues around worker ID and region ID.
Yeah.
How do you address those in the module?
So when you load the module itself, you can pass parameters to it, and one of the parameters here are basically those. You can do that. That's why I like to call them like semi-coordinated, semi-uncoordinated, because they're not fully those.
I don't know if this would be asking too much, but could you give like a small example of maybe like what a post structure would look like using this? Because I'm very interested in actually using it.
So there is, I think, an example on the GitHub repository, but what kind of example were you thinking about?
Just like, name and post or something, like how would you store it? How would you retrieve it? Kind of thing. But if it's on the GitHub thing, then that's fine. I can just look at
it should be there, and the issue with the sending the key will probably get resolved as well. Really?
Redis responded with an error and your
Aha. Bad for me. So it's age set and that key and that value.
Try that.
Yeah, that worked.
Can you namespace? Can you prefix like the user colon Snowflake ID? Because this will give me the ability to. Sorry.
Yeah.
Can you prefix like with the user underscore or colon? Yeah. Can you,
Why do you think the column would work?
Whatever the delimiter.
Yeah,
doesn't
I'm not
matter.
sure. This will probably not work at this point,
Okay.
but I'll add that.
Because that could be useful.
We can do it right.
Come
We
on,
actually
pull up
can
your
do
code.
No
I was
problem.
thinking of a colon, not a column.
Oh, colon. Yeah, whatever. It would still not parse it, parse it at
That
all.
would be nice for namespacing.
Yes, that I totally agree. If we do an get now for the, what was the key? Yeah, oops. Kind of exited it. Totally, so. What did we call it? Key. 4, what do you know? Sorry, it's supposed to be like this. Yeah. Yeah.
Yeah, I've got another one. It just clicked for me that you've got a syntax here where you're creating macros over the Redis command language. I'm a novice with modules. I haven't worked with modules before. Is there sort of an established syntax, or were you inspired by other modules or other command sets?
Veer is the one to blame. The guy who did Redis search. It's kind of, they did that in Redis search, and it kind of stuck in a bunch of other modules. Just allows you for basically keeping almost a similar syntax and just like embedding stuff into things. That's how conventions usually merge. Someone started and the rest follow.
Is there any compatibility issues with Redis cluster or like collisions when you're generating IDs quickly on multiple machines? Or
so if you're using Snowflake, then you would have to pass different parameters in different services of Redis when you load the module. In a couple of days, when I'll have a bunch of other algorithms, because they didn't have any readily available C implementations yet. So other algorithms won't have that problem at all. Obviously, UUIDs, GUIDs, before GUIDs won't have any, even V1, won't have any problems as well. So it shouldn't have any issue. Yeah. Any other question? No? Great. So thank you very much.